Welcome. Let's try to solve some Leetcode problem 322 coin chains. So for this problem, we are given an array of coins and we have an amount. It is, for example, it is 11, and we want to choose the fewest number of coins that need to make up that amount. So for example, the amount is 11, so the fewest gonna be a 5, another 5, and 1. So it's gonna be 3 coins. We can also choose something like 2, 2, 5, 2, and another 1, but in total it's gonna be 6. But we're gonna return the minimum value, which is gonna be 3. If it is not possible, we're gonna return a negative 1. So basically, this is a unbounded knapsack problem. So the difference from the 0-1 knapsack is unbounded knapsack problem. For each of the time, we can choose this item, we can choose this coin, and for the next time, we can still choose this coin. So this is the only difference, but we can still use the BFS with memorization to solve the problem. Yeah. So I'm gonna use define function. I'm gonna call it f, and inside I'm gonna start it from index I, and I'm gonna have a target which is gonna be t. So I'm gonna tag this t. If t is more than the amount, definitely this is not possible. So I'm gonna return an infinity. Because I want to choose the minimum value, so I'm gonna return an infinity. It means it is not possible. So otherwise, I'm gonna tag this I. If I equals to n, definitely I'm gonna return 0 if this t equals to the amount. So otherwise, I'm gonna still return this infinity. It means it is not possible. Now, finally, I'm gonna return two cases. So it's gonna be the minimum of not choose or choose. So if I will not select it, it's gonna be I plus 1 to the next. So what if I select it? It's gonna be I. So this is the only difference. Because for the next time, I can still take this 5, for example. For the first time, I take 5, and next time, I can still take this 5. So this means I will not be updated to I plus 1, but the t gonna be updated to t plus the amount with this I, and we need to also update the number of coins, which is going to be plus 1. This is why finally we just return a 0, because if we go out of the boundary, definitely there's a 0 case. So this is just the edge case. Now we just need to call the function. Let me just prepare this n. It's going to be length of the coins, and I'm going to prepare a result. I'm going to call the function. It's going to be 0 and 0. So I'm going to return result if result not equal to the infinity. Otherwise, I'm going to return not possible minus 1. Now let me just run it. Yeah. I need to change the DFS to F. So yeah, maybe I should use the DFS. Maybe. Yeah. Let me just use DFS. Maybe. Did I do something wrong? So the integer object is not subscriptable. So the integer object is not subscriptable. Let me just check what is wrong with it. So this is t with amount, and I'm gonna plus 1. Yeah, definitely I don't know why it is wrong. Yeah, maybe let me just let me just rewrite it. I don't know why. Maybe let me just use f maybe. Yeah, I don't know why. Basically, yeah, maybe I did something wrong. I don't know. So our check is that for this total, if this is more than the amount, definitely we're gonna return infinity. Otherwise, if it is equal to n, so we're gonna return 0. If t equal to amount, else we're gonna return infinity. And finally, we're gonna return the minimum number of the account. So definitely it's gonna be the f. Yeah, it's gonna be f I plus 1 with this target t, and another one gonna be f I with t plus, oh, it is not amount I, it is a coins I think this is my mistake, because this amount is just number, it is not array. I needed to choose an array, so this is why integer object is not subscriptable. So I'm gonna choose this coins I and update with 1. Yeah. Now let me just run it. Here I should use f, and here I think I need to, yeah, let me just run it. Now as you can see, it works. Now let me submit it to prove that it works. Yeah, as you can see, it works. And for such problem, normally we can also speed up a little bit by sort the coils. So we're gonna use coils.sort, and we're gonna reverse it to be true. Yeah, so this means we're gonna check this 5 first. And while we are checking the next 5 and next 5, maybe it's more than the amount, and we're gonna stop it immediately. So this is why we're gonna reverse the coils array. But there's no influence definitely. The final complexity time complexity gonna be the same. It is I times t. Now let's just check what are gonna be the I and what are gonna be the t. So I gonna be the length of the coils array. It's gonna be 12, and this t gonna be the amount. So it is 10 to the power of 4. So the final time complexity is 12 times 10 to the power of 4. I think that's about it. Thank you for watching. See you next time.